So we have the dot product. And the formula for the dot product is if we're trying to find the dot product of two vectors, vector A, this is how they represented dot vector B. The formula is that the dot product between the two vectors is equal to the magnitude of A, times the magnitude of B times cos theta, theta being the angle between the two vectors. The number you get will be a scalar. It will not be a vector. It will just be a value. Okay? Think of it as a scalar projection of A onto B. That's the idea. Okay, so how far along do we kind of go? It'll give us a scalar number. The other two things that are of importance is the dot product of A dot A is equal to the magnitude of A squared. Okay? And that's something you can actually prove by putting it into here. Okay? The idea being is what would the angle be between A and A? 0. Anyone know what cos 0 is? 1. Okay? And then we'd have magnitude of A times magnitude of A, which is magnitude of A squared. Okay? So you could have proven that with the formula. I just want you to keep that in mind. And also, anytime we have something that is perpendicular, the dot product of the two is 0. And we can also prove that by just memorizing the formula. Perpendicular is what angle? 90. What is cos 90 equal to? 0. So 0 times these two magnitudes will give us 0, right? 0 times anything will give us 0. So we really only need to memorize that formula. These are just two important notes to keep in mind, okay? They've also given us a couple other notes here that if with dot product, our angle between the two vectors is always between 0 and 180, okay? The reason being, and I'll just give you a quick idea here, is if this is vector A and this is vector B, okay? Call that A and B. And if I said this is the angle between them, well, I could always find a smaller angle by just going the other direction. Right? So we always look for the most efficient, the fastest way to get to the other vector. Okay, so we're always going to be between 0 and 180. Okay, we would never use the angle that is larger than 180. And they give us some tips here that if it's theta is between 0 and 90, then the dot product will be greater than 0. If it's 90, we already know it's 0. And if it's between 90 and 180, the dot product will be less than 0. Just some notes. Again, as long as you memorize that formula, you're okay. You can solve all of this stuff on your own. Just some good notes to have. So our very first question, written by a 4-year-old, is that the magnitude of P is 4, and the magnitude of Q is 8. And if theta, being the angle between the two vectors, is 0, they want us to find the dot product of P and Q. Okay? Well, according to our formula, P dot Q is equal to the magnitude of P times the magnitude of Q times cos theta being the angle between them. So we have 4 by 8 by cos 60. Anyone know what the value is?
16.
16 on the dot? Great. So the dot product is a scalar multiple. It's just 16. Okay? That's it. There's nothing else to it. Second type of question you may encounter. In this one, they will ask you to find theta. Okay, so what they've done is they've given you the magnitudes and they've given you the dot product. Okay, so let's write out our dot product formula and manipulate that equation. We know that the dot product of x and y is equal to the magnitude of x times the magnitude of y times cos theta, theta being our unknown. Okay, we'll replace the dot product of x and y with 12 times root 3. And we'll have 8 by 3 times cos theta. We just have to isolate to manipulate cos theta. So cos theta will be equal to 8 by 3. So I'm going to write that as 24 divided by 12 root 3, which will give us 2 over root 3, I believe.
Isn't that backwards?
Oh, yes, you're right, you're right. Thank you. I do that often. There we go. 12, 3 over 24. Okay, so that's going to give us root 3 over 2. So theta is equal to the inverse of root 3 over 2. Anyone know?
30.
Great. You guys remember your functions. Good. Okay. So we have 30 degrees as our theta. We've got it. Those are roughly our easier type questions. This is a difficult type question that takes a lot of thinking. Okay, so this one will take us a little bit to go through. It says that these two vectors, and we'll put them in brackets so it's easier to read, vector A plus the scalar multiple 3, vector B, and our other vector are perpendicular. So these are a vector unto themselves, each of them. It says they are perpendicular, and if the magnitude of A is equal to 2 times the magnitude of B, oh, I forgot to write the final part, find theta, so the angle between those two vectors. Okay, so there's a little of assuming we're going to have to go on about doing here. So we have to find the dot product of the two. And the reason we're going to use dot product is it's going to help us, because if these two are perpendicular, what's the dot product of this vector and the second one? That's right. So we know the dot product of the two are going to be equal to 0 in this case. Okay. So what we're going to do is, because with dot product, our distributive properties are still the same. So if you guys remember FOIL, something you did way back when, we're going to take this A and multiply it by both values, and we'll take this 3B and multiply it by both values. Okay? So that's going to leave us with 4, and the dot product of A by A, that's going to give us the magnitude of A squared. Remember, when we find the dot product of the same vector, it's the magnitude of that vector squared, one of the notes we wrote up above. Okay. The next part's going to be 3, the dot product between B and A, or A and B. We'll write it in alphabetical order, but it does not make a difference. A, B. Oh, sorry, 12. Ooh, don't forget your numbers. Oh, sorry, did I miss this? Hold on. Recap. I'm going to be flustered here. This is the first one. This is the second one. Okay. Should be A, negative A, dot B. Okay. And then our next one, we do 3 by 4, which will give us 12, dot product of A and B. And finally, our last one will be negative 3. And because it's B dot B, it's the magnitude of B squared. Okay? This is a negative value, so we'll just rewrite it as a negative, which means we're now going to have 4 magnitude of A squared plus 11 A dot B minus 3 magnitude of B squared. And remember, this is all equal to 0. Okay? So I've now simplified this, and you'll have a couple questions asking you to simplify like this. The only thing is they've actually given us a bit more information. I already surpassed it. We know that the magnitude of A is equal to 2 times the magnitude of B. So I'm going to substitute A to be 2B. Okay? So this A here is now going to be turned into 4 times 2 times the magnitude of B, okay, squared. And we'll end with our, yes, it will be, the A and B will be squared, but not the 4. Okay, so A and B will be squared, plus 11, our dot product of B, minus 3 times the magnitude of B squared equals 0. Oh, yes, we can. Let's do it one step.
Wait, but that's magnitude.
Oh, yeah, that's right. We can't, because this is magnitude of A, and this is the dot product of A and B again. Okay, and we're going to use that later on to help us find a value of theta. So let's scroll down, because this is magnitude here. This will be squared, which will give us 4 times 4, which will give us 16 times the magnitude of B squared. Does that make sense to you guys? Yeah? Okay. Plus 11 A dot B minus 3b squared equals 2. Let's combine our like terms. Okay. When we subtract them, we'll end up with 13b plus 11a minus equal to 0 is equal to 0. Okay. And we're trying to find the angle between A and B, I believe. That's what the original question was asking. Let me double check to make sure. So now that we've done this, our goal is to find theta between vectors A and B. So we can replace A and B with the dot product. We know that A dot B, the dot product of A and B, is equal to the magnitude of A times the magnitude of B times cos theta, theta being what we're looking for. So we're going to replace this part of the equation with this formula here. So we then have 13 times the magnitude of B squared plus 11 times magnitude of A, magnitude of B, cos theta equals 0. Okay. And again, we can replace the magnitude of A with 2 times the magnitude of B. Okay, so we're going to replace this part now with 2 times the magnitude of B. 13 magnitude of B squared plus 11 times 2 magnitude of B times the magnitude of B again times cos theta equals 0. Okay. This will become 22, and the B times B will be the magnitude squared. So we're left with 13 magnitude of B squared plus 22 magnitude of B squared times cos theta equals 0. Okay. Now remember, the goal is to get theta by itself. So we're going to move 13b squared to the other side. It'll become a negative. And then we're going to divide by 22, and there should be a squared here. 22 times the magnitude of b squared. Okay. So the next step will look like this. Cos theta is equal to... because this is multiplied by cos theta, so we can't do that. Okay, so we get negative 13 magnitude of b squared divided by 22 magnitude of b squared. So I kind of did 2 steps in one there for you guys. Okay. Magnitude of b squared can cancel out. Okay. So we're left with theta being the cos inverse of negative 13 over 22. And if somebody could kindly help me out with that. Anyone know what that is? 26. So the angle between our vectors A and B are 126. So a lot of stuff in 7.3. The first 2 parts really simple. The last one relatively difficult.